If you're a student, then you need to know this. Newton's laws of motion and viscosity are everywhere around you. Let's break it down. Newton's first law says an object at rest stays at rest, and an object in motion stays in motion unless acted upon by a force. So if you're coasting on a skateboard, you'll keep going until you hit that bump. Now, Newton's second law is all about force and acceleration. Force equals mass times acceleration. Push a light shopping cart versus a heavy one, and you'll see the difference. Lastly, Newton's third law. For every action, there's an equal and opposite reaction. Jump off a boat, and the boat moves back. And then there's viscosity. It's like the thickness of a liquid. Honey flows slower than water because it's more viscous. Think of it as liquid friction. So, next time you glide or slide, remember, Newton and viscosity have got your back. Keep exploring. Welcome to Chapter 2. Detailed explanation of Newton's first law. Inertia is the resistance of any physical object to any change in its velocity. An object will keep doing what it's already doing unless something forces it to change. For example, a book will stay at rest until you apply a force to move it. In a car that suddenly stops, your body keeps moving forward due to inertia. Try placing a card on a glass with a coin on top. Flick the card and the coin drops into the glass. The coin stays in place due to inertia and drops down because of gravity. Understanding inertia explains why seatbelts are crucial. The seatbelt provides the necessary force to change your motion, keeping you safe. Newton's first law, or the law of inertia, is a fundamental principle that affects everything. It's a cornerstone of physics that helps us understand the natural world. Stay tuned as we continue to explore more fascinating concepts in the world of physics. Welcome to Chapter 3, Detailed Explanation of Newton's Second Law. Newton's second law states that force equals mass times acceleration. F equals ma. This explains how an object's velocity changes with an external force. For example, a 1,000 kg car pushed with 2,000 newtons accelerates at 2 nsr2. Pushing a shopping cart shows this law. More force means faster acceleration. In soccer, a stronger kick accelerates the ball faster. Engineers use this law to calculate rocket launches. Newton's second law links force, mass, and acceleration, essential in physics. Keep questioning and keep learning. Welcome to Chapter 4. Detailed explanation of Newton's third law. Newton's third law states that for every action, there is an equal and opposite reaction. This principle is fundamental in understanding interactions between objects. Imagine you're standing on a skateboard and you push against a wall. The force you exert on the wall pushes you back in the opposite direction. This is Newton's third law in action. Similarly, when a bird flaps its wings, it pushes air downwards, and the air pushes the bird upwards, allowing it to fly. This law is also crucial in engineering. Consider rocket launches. The engines expel gas downwards, and the reaction force propels the rocket upwards into space. Newton's third law helps us comprehend the balance of forces in everyday life and advanced technology. Keep questioning and keep learning. Welcome to Chapter 5. Newton's laws in everyday life. Now that we have explored Newton's 3 laws of motion in detail, let's see how they manifest in our daily experiences. Consider when you're driving a car. Newton's first law explains why you feel a jolt forward when you suddenly stop. Your body wants to keep moving forward due to inertia, while the car stops. This is why seatbelts are crucial. They exert a force to stop you, counteracting your inertia. Next, think about a game of soccer. When a player kicks the ball, Newton's second law comes into play. The force applied to the ball determines its acceleration and direction. The harder the kick, the faster and farther the ball travels. Finally, let's revisit the example of swimming. Newton's third law is evident when you push water backwards with your hands. The water pushes you forward with an equal force, propelling you through the pool. Understanding these laws helps us comprehend not just extraordinary phenomena, but also the simple actions we perform every day. From riding a bicycle to playing sports, Newton's laws are always at work, shaping our interactions with the world around us. Keep questioning and keep learning. Welcome to Chapter 5, Understanding Viscosity. In this chapter, we will delve into the concept of viscosity, exploring its definition, types, and significance across various fields. Viscosity is a measure of a fluid's resistance to flow. Imagine pouring honey and water. While water flows easily, honey moves much slower. This difference is due to viscosity. Honey has a higher viscosity than water. Viscosity can be categorized into two main types: dynamic viscosity and kinematic viscosity. Dynamic viscosity refers to the internal friction within the fluid, while kinematic viscosity considers both the fluid's internal friction and its density. To better grasp these concepts, let's conduct a simple experiment. We'll compare the flow rates of different liquids, such as oil, water, and syrup, down an inclined plane. As we observe, the syrup moves the slowest, demonstrating its high viscosity, while water flows the fastest, indicating low viscosity. Viscosity is crucial in various fields. In the automotive industry, engine oils with appropriate viscosity ensure efficient lubrication and reduce wear and tear. In the food industry, controlling viscosity is essential for product consistency and texture. Even in medicine, understanding the viscosity of blood can aid in diagnosing and treating certain conditions. Visual aids can further enhance our understanding. Imagine a river flowing smoothly versus one obstructed by rocks. The former represents a fluid with low viscosity, while the latter, with more resistance, depicts higher viscosity. In summary, viscosity is a fundamental property of fluids that plays a significant role in numerous applications. By understanding its principles, we can better appreciate the behavior of different materials and enhance various technological processes. Stay tuned as we continue our journey into the intriguing world of physics. Keep questioning and keep learning.
Like, share, and subscribe to our channel for more updates.